Hello, everyone. Welcome to our latest edition of Copy and Capture, where we're going to be talking about intelligent document processing. Thank you for joining. Hopefully you have your coffee. I do as well. Since we've had a really strange, should we say, climate change influenced heat wave here in the Colorado area. I've been continuing to drink my iced coffee, but it's still French pressed. So wherever you are, whether it's morning or afternoon or early evening, hopefully you have some little injection or jolt of something delicious, maybe a caffeinated beer, who knows. So anyway, today's topic is handwriting recognition. And why we're talking about it is a lot of really interesting things have come into play over the last several years that kind of drive me to revisit this topic and talk about what's going on. People that know Periscript might be saying, well, why are we, of course we're talking about handwriting recognition. Periscript, one of it's well known as being the quote unquote handwriting recognition experts, and we do all those challenging things, but nothing stays the same. As a former CEO of mine said, software is like a shark. It needs to keep swimming or it dies, even though research has shown that there are sharks that sleep and don't move and they don't die. It doesn't matter. So what's going on here? Why is handwriting still so important? How can it be so important now? Why is there kind of a new way of looking at things? At least the way I look at it is there are at least three main reasons for that. It's still one of the most difficult parts of information or business information to wrangle, and there's still quite a bit of it out there. So while inordinately the amount of document-based information is digitally born, and therefore it's not handwritten versus scanned image, and definitely if you look at it in terms of pie pieces, how much of that information is text versus handwritten, smaller and smaller amounts of that information is handwritten, but there's a lot of really important information that can still be had within handwriting. So it's and definitely within case management and business processes, it's a lot easier to write something down on paper and take a picture of it, and then in some cases then use a web form. So there's a lot of different reasons why, but it's still a difficult thing. I would say this is pretty much the case. Why isn't Periscript a billion-dollar company? Because and it's not. If anybody was on here is thinking that we're like we deserve to be amongst the FANG companies, the Facebooks or whatever, I hate to break it to you, but we're not. And the reason is because handwriting recognition, even though there's a lot of critical information, typically you had to apply it to high value business processes where there was a lot of cost. It was a critical level of operations. And the reason being is because there's a lot of work to be done in being able to transcribe handwritten information into something that a computer can read. Things like check processing. When Check 21 came about in I think 2000, actually no, it wasn't 2000, it's 2001. Basically was to handle or to enable banks to continue to be able to process checks in light of transportation issues that came about when airlines were grounded. It was a critical operation. Government mail automation, government mail, mail and the post is a critical operation. Delivering things correctly and then in this quickest time possible is the key there. Some limited form processing. I would say limited because not all form processing is critical, but you would argue that any types of forms that onboard a customer or initiate a transaction, and definitely within the government space, this is critical information. So handwritten recognition was really popular and continues to be very popular in these areas, but it was limited to those types of things. So because the nature of the technology wasn't really there to be able to make it easier so you could apply it to everything. So it was really a nice to have for everything else except for the critical operations. And all of this comes down to the complexity of the configuration and the overall performance that we have there. So I'm going to take you into a little bit of history as to understanding why that is so, so that we can juxtapose that into where we are now, because quite exciting things have been happening in terms of the technologies and performance. So if we were to look at the different types of information out there, business information, text, certainly comes into play. Text-based information, whether it's typewritten information from a typewriter, God forbid, maybe there's some old archival information, but most of the time it's computer-based, so we call it machine print of some form. And what you see here are all sorts of different fonts that are available on different types of computers, whether you use Macs or PCs or whatnot, or phones now. When you're typing in text, you're using a font. And the cool thing here is it's pretty easy to train software to understand what a font is. Fonts are highly reliable, very consistent. They look the same from one computer to the next typically, and therefore you can train a computer with computer vision or software with computer vision to understand how to transcribe a font of text into some sort of type of easy to understand language or machine readable type of information, whether most of the time when it's scanned. So they're easy. Let's just call it easy. There may be 1,000 fonts out there, but training software on 1,000 fonts is not a hard thing. But let's take handwriting and think of it as a font. There is a font, a unique font for every person on the planet that writes information. So I have a different font from my brother and my wife and my friends. Every one of us has fonts. And then how that information is conveyed on documents also can make it challenging. So here you see here, we've got, text, that's a machine print, but then we've got the written word of text in boxes, but these are dropout forms. So the underlying structure of the form drops out, leaving only information. And then we have, free form handwriting, and then we have cursive, and then we have structures that can't be removed. All these represent challenges that are, can be an order of magnitude more difficult than transcribing machine print fonts into machine readable text. So that's, how do we overcome that? In the days or years leading up to the past couple, about 2018, how would we overcome that type of challenge? So basically, when it comes to handwritten information, and it also can be applied to machine print when you want to really find specific information on a document, you need to add context into it. So that's basically, context is knowledge about what needs to be extracted. Simple enough. It can be as simple as a concept of telling the system it's a number versus this is just using the alphabet versus this is a mix of alphabet digits, or not alphabet characters, but numeric characters and everything like that. It could be a vocabulary or a dictionary of expected words or phrases. So things like if you've got account numbers in a system, then certainly you've got a database of those expected account numbers, and you can use that, or you can bring to bear a dictionary of names or other types of common terms. An example is claims adjudication, where we can take a list of known ailments or services popular with ICD-10 codes and use that as a way to aid with recognition, or expected patterns. All of these things we would apply to the scope of handwriting recognition to aid with those recognizers and overcome this problem of a billion fonts, so to speak, a billion different ways to write information, all that variance. So this information was added at recognition time, what we call, to help these handwriting recognizers narrow down the millions of potential options or answers down to the most likely. And as you can imagine, identifying the context and applying that context requires you to really scope down a project. And in some cases, it's just not possible, right? Perfect example is, or a potential example is, a handwritten vehicle identification number, otherwise known as a VIN code or a VIN number, where there can be quite a bit of variance. It's an alphanumeric, so we have this common challenge of identifying O's and distinguishing them from zeros and S's and 5s and things like that. So all of these this type of effort led to handwriting recognition being applied to very specialized cases. As we mentioned, check recognition, where you can define the scope really well, or postal automation, where you can define the scope of address blocks very well and then add a lot of information to it. Here's some pictures of how we would do that. So we're looking at both the individual characters of a name, resolving those into individual letters, and then we would take that and run it against a database of names. And arguably, the goal is that Natalie is resolved as one of the top names here, and we can use recognition and this database to arrive at that answer being presented as the most likely correct answer. So hopefully you got a decent grounding into the complexities of handwriting recognition. A lot of companies tried handwriting recognition believing that it was as simple to use as OCR for text, and found that it wasn't. And their expectations were probably set higher than what they should be, and they're like, this doesn't work, so they just drop it. Okay, so what's changed? Moore's Law. It's interesting, Moore's Law has been around for well on 3 decades or more. What Moore's Law is it basically says the power of computing doubles every n number of years. And what that gives us is the ability to take things that would have typically been really difficult to do because it takes a long time, and it makes it a lot easier. So Moore's Law continues to just forge on, and with quantum computing, I would say that it's going to have an inflection point someday, and world's going to change significantly. So computing power continues to move, and cloud-based deployments where you don't even have to buy the hardware certainly have helped. Data accessibility. So the ability of taking examples, because in machine learning, and machine learning is definitely used within the confines of handwriting recognition, we train systems, computer vision, to understand what is on a written page. But you need a lot of data for that, right? Because I mentioned it's a billion plus fonts out there. So the more examples we use of different writing styles, is what we call it, the better the software will perform. So we've got access to data by virtue of the internet and bandwidth that allows us to not have to mail information back and forth or FedEx it. And that's really cumbersome, and then scan it all in. We can dip into clients' data, obviously with their permission. For those of us that are coming across the Atlantic, we are very GDPR compliant, but we have access to that data, so that aids us a lot. And then the last one is deep learning. Deep learning is a variety of neural network that adds a number of what we call hidden layers in between the inputs and the outputs, and all of these different hidden layers consist of different nodes that are trying to figure out things, right? When we apply deep learning to handwriting recognition, we can use a lot more information. We can process a lot more of the information that we are inputting into the system. It's able to do a lot more intensive computing, getting through there, figuring out and identifying what's right and what's wrong to just an amazing amount of detail than what we had with traditional neural networks, all because we've got more data, more computing power. And so the end result is significantly improved performance on handwriting recognition. So what does that look like? Now, I'm going to deviate from previous coffee and capture chats, and I'm going to show you a little demonstration. So this is not a product, what you see in front of you. This is an application, we call it like a test harness, so to speak, which allows us to input information and visualize and see what's going on. So here you see some handwritten page of information. Now, just 3 or 4 years ago, we would not be able to do anything with this. We could potentially parse it and do word spotting, where we're using dictionaries of words or patterns or whatnot to be able to locate specific information. But again, we're adding context, right? But the ability to actually transcribe all of this information without having to do much to it, or if anything, wasn't there. But now with the ability to have access to a broad range of information, have access to much greater amounts of computing power, and of course applying that using deep learning, we can do things like what you're about to see here. So I'm going to click this button, and what it's doing is it's using deep learning algorithms, looking at different types of curvatures, and we're breaking lines up and words and characters, and we can transcribe this into, you can see here, text that's underlying it. And I didn't do a single thing other than import this page and run the recognition on there. My computer, which is a pretty decent computer, along with deep learning, along with the pre-trained algorithms, is able to resolve a lot of this information without anything, to the point where I can even search here and find the information. And if I wanted to take all this information and then apply things like natural language processing or some other type of pattern recognition, all of this is now available to me, and in a lot quicker way, which enables applications of handwriting recognition to business problems that can really use it, that might have been off limits because you couldn't apply that or locate that type of context, or it was just too expensive to set it up and configure it. You can now expand the use of this into other types of business applications, which is pretty exciting. So the upshot. Parsing this handwriting information, I talked about the ability to do word spotting. We've been able to do that for quite a while now, but it still requires a lot of configuration. It's a lot easier. You don't need to spend a lot of time with adding context or optimizing it. But I will say this, anytime you can add context, anytime you can specify to the software what you're really looking for, the performance is just going to shoot through the roof. But you know, the baseline performance is incredible now. And we have a broader applicability, because now that we don't need to provide, at least up front, as much context and have to spend a lot of time for these configurations that can be pretty complex, we can accommodate simply more use cases. So the idea of being able to parse handwritten correspondence in like a prior authorization or claims adjudication or within any type of core business process, we can do that now. And we can do that almost to the level of the out of the box capabilities of OCR. It's not quite there yet, obviously, because you know, OCR again is a finite number of fonts that we can train against versus handwritten information. But as you can see, I was able to take a page worth of correspondence or handwritten information and resolve that and transcribe it into mostly accurate data. You know, we're going to have some inaccuracies there because of obviously the font. So it's not there yet, but you know, if I can get 90% of the characters or the words of a page of text of the handwritten information, there's a lot of significant things I can do with that. You know, I can then apply NLP technologies to identify at a basic, and I don't even think it even requires NLP to do sentiment. Is this person angry, or are they having problems, or are they frustrated? But I can certainly apply other types of things to locate or to parse information to identify a patient's condition or likely illness and things like that. But, and this is the key, keep in mind that transcribing data is really only the part of your objective. It's just like OCR. OCR unto itself just yields you text. Handwriting recognition, even at a page level, yields you text. It's what you do after it. It's how you find the specific information and structure that. And it's how reliable the data is. And it's the ability to apply confidence score thresholds to enable straight through processing, and all of that really hard stuff is well beyond the confines of just pure handwriting recognition or pure OCR. It's kind of the data science and the art of intelligent document processing that still you have to bring to bear. And that's where we spend most of our time anyway. So while we've developed this handwriting recognition and we continue to do that, most of the efforts that we have are an interpretation of that information. So that is still the big thing here. So with that, I will open up to any kinds of questions if there are any, and you know, now or after the fact, and go there. So Rebecca, do we have any questions?
There's just one question right now, and that is, what is the difference between implementing a handwriting recognition intelligent capture project versus a machine print one?
Well, yeah. So yeah, let me restate that because maybe it wasn't entirely clear, but the primary difference is if we're talking about intelligent capture or intelligent document processing, most organizations wrongfully just call it OCR. As I said, OCR or even handwriting recognition is a step along a journey of converting document-based information into structured information that can go into a database that can be shepherded along, whether it's enabling a transaction or enabling case management to move forward and to be able to do things, applying additional analysis. All of that requires configuration of and telling the system what information you're looking for. All right. So you typically will do that after OCR, although we use techniques where we do it during the process of doing recognition. But when we juxtapose OCR, which processes text, machine print, versus handwriting recognition, the typical difference was you needed a lot of that, what I called context, to be able to resolve all the different fonts into text, something that a computer can read. So that was the before. Now there isn't a whole lot of difference now that we're able to treat handwriting without having to provide a lot of context to get that baseline text. So I would say we're getting closer to being able to treat the handwritten bit of information as we would with text-based information, and then focus solely on those types of techniques and routines to be able to look to structure the data, whether it's using regular expressions or keyword value pairs or applying different types of parsing and text tool analysis tools and whatnot. So we're getting closer to being able to treat them as one and the same, but there's still a level of performance that is different. So if I can transcribe 90% of the words of handwritten information, typically I can do it to 98 to 99% for text. So hopefully that'll answer your question.
Excellent. Thank you, Greg. That's it in terms of the questions today.
All right, cool. Well, once again, I think we're 8 minutes from the top of the hour. Thank you very much. And we'll see you again soon when we start this up again.
Thanks, Greg.